All right, here are our 5.6 notes. Let's go ahead and start with example 1. It asks us to tell whether the ordered pair is a solution to the inequality. So what we need to do is just plug in our x and y values and test it. So I'm going to plug in 2 times -1 plus 9 and see if that's equal, if that's less than -3. That's -2 plus 9. Is that less than -3? And I get 7 is less than -3, which is not true. So I'm going to put a no. That means it is not a solution. Let's go ahead and go over to 1b and do the same thing. I'm going to plug in 2 for my x, minus 3 times -2 for my y. Keep the greater than equal to 8. 2 plus 6, is that greater than or equal to 8? And I get 8 greater than equal to 8. And because of this equal to sign right here, that is the reason why this answer is going to be a yes. It is a solution because 8 is equal to 8. So there are some on your owns right here. Go ahead and pause the video, and then when you unpause it, I will go through these ones as well. All right, welcome back. Let me quickly go through these ones. So this first on your own, you would have -2 plus 2 is greater than 0. 0 greater than 0. No, that's not true because 0 is actually equal to 0. The second on your own, plug in zeros. You can get 4 times 0 minus 0 is greater than or equal to 5. I get 0 is greater than or equal to 5, which is no, not true. Number 3, I'm going to put 5 times -4 minus 2 times -1. Is that less than or equal to -1? I get -20 plus 2 less than or equal to -1. I'm going to get -18 less than or equal to -1. That is true, so I'm going to put a yes. -18 is less than -1. Example on your own, number 4. Let's go ahead and put these in here. I'm going to get -2 times 5 minus 3 times -7 less than 15. -10 plus 21 less than 15. 11 less than 15. Yes. All right. Let's move on to the meaty part of our notes today, which is actually graphing linear inequalities. So we're going to graph a boundary line, and we use dashed lines as sort of like our open circles. And that's what this says here. Use a dashed line for less than or greater than symbols. And then if you have a less than equal to or greater than equal to, you're going to use a solid line. That's sort of like a closed circle. So if you want to make a little note here, dashed lines are similar to open circles. And then your solid lines are sort of like a closed circle. Because closed circles, there's nothing missing. Where an open circle, so this would be a solid line, and an open circle, there's stuff missing. So we have dashes because there's gaps missing. So what we do is we graph the line and then just make sure if it's solid or dashed, and then we test a point that's not on the line to determine if to shade. If the point works, we shade there. If it doesn't work, we don't shade there. So let's go to this first one right here, example number 2. We're going to graph y less than equal to 2. So this, if you remember right, is going to be an equation where the y crosses the y-axis at 2, and is going to be a solid line because of this equal to symbol. And it's also a horizontal line because it's a y-only equation. So there's the first part. And then when it says to test a point, I would say try 0, 0 first. And then if that doesn't work, because 0, 0 is on the line, pick something with really easy numbers like zeros and ones. So let's go right here. What I like to do is put a little point on this where I'm testing. I'm testing right there. So I'm testing 0, 0. So if I go up here and I say test 0, 0, I'm going to put in 0 for y less than or equal to. Is 0 less than or equal to? Yes. So what that yes means is the yes means I shade. I'm going to shade this side. So I'm going to go ahead and shade this side of the graph. There we go. Let's look at example 3 here. Oh, what we should do, because it says to graph this, maybe what we should do here is to put in y equals mx plus b first. So I'm going to add x to both sides. And I'm going to get 2y is greater than x plus 2. Divide everything by 2. And I'm going to get y greater than 1/2 x plus 1. That's what I need to graph here. So I go up to 1, and then a slope of, so this is a intercept of 1 and a slope of 1/2, and this is also a dashed line. So I go up 1/2, up 1/2. I'm going to keep doing this for a while to make this pretty accurate. Then I can go backwards. Then you'll have a ruler to be able to do this on yours. But currently I don't have a ruler on me, so I'm just going to do this by hand. Oops, actually I'm going to undo that. It has to be dashed. So make sure it's a dashed line. See, it's not solid. Again, I'm going to test a point, maybe 0, 0. So if I test 0, 0, I'm going to put it in the original so I don't screw anything up. Negative 0 plus 2 times 0, is it greater than 2? I'm going to get 0 greater than 2, which is a no. No means no shading. So I don't want to shade on that side. So if I don't want to shade there, I want to shade on the opposite side, which is going to be up here. So I'm going to shade way up here. All right, last but not least, I'm going to skip the on your owns that are right here. And I'm going to do the story problem. It says, at most, spend $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound and apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy. This is sort of like the last story problem that we did when we were writing story problems. So what we know is we have $2. Whoops, helps if I maybe make this where you can read it. All right, $2.50 times every grape. I'm going to use y, so my y here is going to stand for my grapes, and I'm going to use x for my apples. So $202.50 times every grape plus $1 for every apple. That'll be my x. Actually, let's flip-flop that. I only say that because it'll be easier to solve for y then. So let's erase this. Since apples are $1 a pound, let's do y's for apple and let's do x's are grapes. Okay, so that would be 2.5x plus y. At most means I can get to that or I can spend less. Less than equal to 10. And notice when I switched my apples to 1, that meant my y had a 1 here, and I don't actually have to divide by anything when I put this in slope-intercept form. So let's go ahead and rewrite this. This is going to be y less than equal to negative 2.5x less, I was going to put a less than, that's not a less than, and then I'm going to put a plus 10. Now, negative 2.5, just so you know, is negative 5/2. That'll help us with our graphing. So what I'm going to do here is I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm actually going to count by twos here. So maybe be a little bit easier. 1, 2, 3, 4. When I say 2, skip every line. 4, 5, 6, 7, 8, 9, 10. And then maybe down here I'll do the same thing. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. I might make it easier to graph. All right, so my intercept is up here at 10. I'm going to go down 5, so that means go down to 5 and go over to 2, put a point, and I'm going to go down 5 again, over to 2, which is the 4. This is a solid line. So I'm going to connect these. And then I'm going to test a point. Let's test 0, 0. So is 2.5 times 0 plus 0 less than or equal to 10? 0 is less than or equal to 10, which works. So I'm going to quickly shade everything that's in here. All right, so this is my solution, any ordered pair in there. Now it says identify and interpret two solutions. So what does this mean? If I look in here, let's find 2 points. Let's find 1, 1 maybe, and let's say 2, 3. That means I can buy, let's see, what was it? X's are grapes. 1 grape and 1 apple. I can also buy 2 grapes and 3 apples. All right, I'm not going to do this next on your own either, but if you want to, you can reach out to me individually and I can help you with that. But best luck. If you need anything, go ahead and ask for help.